in 8.1 to 8.3, we were looking at permutations. And permutations was always putting things where the order matters. This next section looks at something called a combination, where the key thing is that the order does not matter. So we're going to look at how that changes our counting. Okay? So the example that they have is they have 3 books from 4. So you have 4 books in total, and you want to do something with 3 of those books. In a permutation question, maybe you had 4 books, but your bookshelf had only room for 3 books. So you're like, well, how many ways could I arrange 3 books on my bookshelf? But a combination question is more like, you just won first prize in, I don't know, poetry contest. And the prize was there's 4 famous poetry books, and you get to choose 3 of them to take home. 1 you have to leave back. The teacher wanted to keep 1 of them, so they said the prize is only 3. So you could choose books 1, 2, and 4. And if you chose book 1, 2, and 4 and you went home, you could arrange them in your shelf these different ways. This counts as 1 combination. It would count as 6 permutations. Because it's not, you're not going home with different books if you're like, oh, I don't want to choose 1, 2, and 4. I'm going to put them back. I think I'll choose books 4, 2, and 1 and go home. And you'd be like, you just took the same books home. Right? You've got the same prize as you did before. The order doesn't matter now when it's a prize and you're taking them home. So choosing 1, 2, and 3, those are all the combinations. If we do this all the way, with 4 items, choosing 3 of them, there's only 4 combinations. But in permutations, we had 24. In permutations, we could have done this as spaces. And got 24. In combinations, how do we do this now? And the idea is that you could take your permutations and say for each 3 things, there's 6 permutations, so I could take my 24 and divide out the order. How many ways can you order 3 things? 6 ways, 3 factorial. If a combination says the order doesn't matter, just like identical objects where we divided to get rid of something, we can divide here to get rid of the order. So our permutations formula, or our combinations formula, which is going to look like this, is just our permutations formula with the order divided out. And they've got this formula on the next page. So in the formula, I'm just going to rewrite it. And I'm going to make a little note in blue here and put a box around that part. That's your NPR formula. The only thing new with the combinations formula is this part which divides out the order. Now we hardly use the permutations formula because the spaces were so easy to think about and easy to use. We will use the combinations formula a ton. And if you ever study this later on, like for our course, we're always going to use this notation of the NCR. A lot of textbooks later on use this notation with an N and an R in brackets. So just if you ever see that. And our language For the C, we often read it as and choose R, because you're choosing things where the order doesn't matter. I don't know what the P do you say, and pick R, and picking things, placing, maybe placing, because then order matters, and place R, and choose R, I'm not sure. But the key thing that's different between a combination and a permutation is, does the order matter? Now these questions are all going to get mixed up on your test, and they're all going to get mixed up on the exam. So your first thing going into the question, you're going to read a question, it's going to sound very similar to a permutation question, and your first question is this a question where the order matters or the order doesn't matter? If the order matters, then I'm going to use my permutation strategies. If the order doesn't matter, I'm going to use my combination strategies. And some of the strategies, like cases, you can have cases in combinations questions, cases in permutations questions. So we're going to just start looking at how do these questions look and how are they different. And a lot of these have huge applications to things that you experience in real life, like lotteries. How do lotteries work? What are your chances of winning? What does it mean when someone wins? Why are the prizes so big? What is it like? We can look and even like, what are the psychological benefits or reasons why lotteries exist? So here's the Keno lottery. I don't know, most people aren't really too familiar with the Keno lottery, but you have 80 numbers and you choose 20. And it doesn't matter what order you choose them in. If you chose 10 as your 15th number and 10 appeared first, that's still good for you. It doesn't matter as long as that number comes up. So the order doesn't matter. And you have 80 items and you are going to choose 20 of them. And actually the combinations formula I find is really easy to remember compared to the permutations formula. Because with the 80 choose 20, you're going to have 80 factorial on the top. On the bottom, you're going to have 20 factorial, and you're going to have one other number, and the other number always is going to be, so the bottom two add up to the top one. So it's actually going to be, with that strategy, really quick, like if I put anything down, 8 choose 3, it's going to be like, oh, 8 factorial, 3 factorial, 5 factorial. Without having to plug things into the formula, you can just write it out right away, which is kind of nice. The combination, I mean the permutations formula, I still felt like you had to like look at your formula sheet and plug things in and think a little bit. With the combinations, it's so easy to remember that you don't have to go to your formula sheet as much. So that's really nice. And unfortunately, if you try to type this separately into your calculator, like if I take my calculator out and I start with the 80 factorial, that number's too big, I think. Many calculators can't handle that. Like, I'll check if my calculator is feeling it today. Calculator, can you handle 80 factorial? No! It's like, it exceeds the memory of this calculator's abilities. But if I go to math and over to probability and I find the combinations button, it can calculate this. 3.535, this e to the 18 says times 10 to the 18. Now, this is the Keno lottery. It's not really a lottery that's well known, I think, in Canada. Here's one, I think it's written, have you heard of this one? Lotto 649? That's like a pretty famous Canadian lottery. And it's very similar to the Keno lottery, except Keno you have to pick 20 numbers. Lotto 649, you choose 6 numbers from 49. So the total number of possibilities is 49, choose 6. We go to our calculator and put this up. Oh, I'm very close to remembering it. It's like, I'm going to be off. I think the middle numbers I'm off. It's like 13,972,960. All right, I think that's off. I'm pretty sure that's off, but let's check it out. 49, math, probability, choose, 6, 13,983,860. Okay, so I was only off by like 30,000, 40, 50,000, I'm not sure, but not too bad. 13,983,816. Where did I get it? I don't feel like I did. 983,816? Oh, yes. There's some cool things we can think about here. Okay? When do people start getting excited about this lottery? Usually when billboards go up and it's like 35 million, 40 million, 50 million prize. Once the prize gets really, really big, people start going crazy. Now your chances of winning the lottery, if you buy one ticket, are 1 in about 14 million. That is not very good. If you think that's very good, spend some time taking out a quarter and flipping it. If you get heads 21 times in a row, go buy a lottery ticket. Well, maybe not. Because if you get heads 21 times in a row, it's actually not enough. I don't even think 22 is enough. Go back to my calculator. Heads 21 times in a row, chances of that are only 2 million. 22 times in a row is still not enough. 23 times in a row, still not enough. 24 times in a row is more. So if you flip a coin and get heads 23 times in a row, that is more likely to happen than winning this lottery. So the first thing I want you to know in mathematics is that know your probabilities. If you go out today after math class and say, I'm going to buy a lottery ticket. First of all, I don't know if you're allowed to. I don't know what age group. You could be like, slip your mom some money and say, hey, buy a lottery ticket for me. Right? On the edge of illegal, I'm not sure. But know your chances. You could probably go home tonight and spend 2 hours flipping a coin and not even get 7 or 6 in a row. And I don't want you to go home and just flip a coin all night. You're better off doing some math homework, would probably be more beneficial for you. But the chances are really, really low for winning. However, when it gets to 50 million, the next week you hear in the news, somebody won. Why is that? Well, when the prize gets really, really big, what do you think? Do more or less people buy it? More people buy it, right? And the reason it gets big is because the week before nobody won. So all that money gets pooled to the next week to become bigger and bigger and bigger. And then it gets to a week where it's really big and a lot of people buy it. In fact, in Canada, probably more than 14 million people buy a ticket. Or more than 14 million tickets are sold. Now that doesn't guarantee that everybody bought a different ticket. Some people will buy the same ticket, right? Sometimes there's more than one winner. But once more than 14 million people buy it, there's a chance that someone could have picked that right number. Just by the sheer number of guessing, right? Like, I could do something very less probability here, right? I could roll this 30-sided dice. What number did I roll?
21.
No. See, chances of getting it right are not very good, right? It's 1 in 30. Way better than winning the lottery. But if we went through the whole class, someone might get it, right? If I got you all to write down a number on a piece of paper right now, we can do that quick. Quickly just write down a number from 1 to 30. Maybe everybody pays $1. There's 20 of you. prize is 15, of course I gotta get my cut, right? Okay. You guys, everybody write down a number, have it in their head? Right? Did anybody pick 27? No. Oh, I gotta keep all the money. Oh, I like this game. We should play these games. It's like, we're starting to date. I think, you know what, I'd be in trouble, but I could, gambling's addicting. And I feel like I'm an okay teacher. I could probably get you guys really addicted, right? And then it'd be like, oh, we gotta gamble at the beginning of class today, and I'm slowly making money until I get fired. No, okay, maybe not a good idea. But if it is on your bucket list to win the lottery, you can do it. I think the lottery ticket's $2 now. For $28 million, you could buy every number. And you could guarantee to win the lottery. Right? So if it's at 50 million, right? I'm just going to go to my bank and say, hey, I'd like a loan. They're like, okay, come sit down. How much would you like? I would like $28 million. They're like, what? Oh, don't worry. I'll pay you back next week. I'd like 28. Well, what would you like to do? What kind of business? I'm going to win the lottery. I think the approval sample is not going to come on that one. But you're like, oh, this is a good idea. The lottery is 50 million. I borrow 28 million. I buy every single number possible. I'm guaranteed to win. What could possibly go wrong?
Somebody else could win, then you split the money and you're actually in debt.
Yeah, and you go bankrupt. You take that chance, and then the bank is out of money, right? And that's why they won't approve you in the first place. But yes, if something goes wrong, like somebody else wins, and you have to split it, now your 50 million is cut in half, and you get 25, and you go to the bank and say, I'm sorry, I had 28 million, I'm only short 3 million. But don't worry, you can lend it to me again next week, and maybe I'll win the next time. Okay, that's not going to happen, but it is a possibility. Right? Had someone who once had a scheme of like getting people to donate online, win the lottery for charity. So people would donate $2 or whatever, and if the GoFundMe ever hit the 28 million that they could buy every lottery ticket, then the website would then buy every lottery ticket and guarantee that they win on a $50 million one. And take all the winnings and give it to charity. In the meantime, the scheme was this. Here's the scheme. Okay? The scheme was, while we're waiting for it to get up to the 28 million, while people are donating online, we invest it into an account that pays X amount interest per month. And we'll donate it all to charity once we hit the 28 million. But whatever interest we make on that 28 million while waiting for it to get there, that company would keep. And if it never makes it to 28 million, they just keep making interest and keep the program running. That sort of seems like a little bit devious of a scheme, but might work, right? If it works for you one day and you swindle people out of money, and I get a box of chocolates when I'm 80, I'm like, oh no, someone listened during class. This is not good. This could be disastrous. Okay, so crazy thing is your chances of winning are very, very little. However, it still might be worth it for you to play. If you're paying your $2 to buy a ticket, if you are playing because you need that $2 to make you 14 million, that's not, you have to know that when you're playing, that you are most likely not going to win. Play your whole life, you're most likely not going to win. But if that $2 allows you to have the greatest one-day fantasy of like, what if? Right? That's really what that $2 does. Is you pay the $2, and then you get a whole day of like, I wonder if I'm going to win. And you imagine what you would do, right? If you won, you'd be like, I'd buy my math teacher at least a box of chocolates, right? So you can imagine all the amazing things, and then the next day you don't win, and the fantasy has to go away, right? But you could still have that. If that $2, if that fantasy is worth it for that $2, perfect, okay? And there's a guy online that had a video about when Britain changed theirs to Lotto 659. With 59 choose 6 is a much bigger number. But if you got 2 numbers right, you got a free ticket for the next week. So what happened is the prizes were bigger, so your fantasy could be more amazing when you had a ticket. Your chances of winning were less, which made the prize bigger and bigger and bigger, but people got free tickets, so their fantasy was able to last for a longer time. He's like, it was actually better bang for your buck because you lose the money in the end, but then your fantasy could continue, right? Like, you're not going to win. If you want to save money, you can imagine things for free, right? I don't know if I've told you this. This video's getting super long. I'll tell you the numbers. I'll end the video. I'll tell you one more story. So, here, 4, 5, and 7. I don't know if the online video needs to hear all of my stories.